In this lecture, I'm going to summarise how to test a water damaged building. I strongly suggest you watch this at least 3 times because it will really summarise everything that you've learned in this subject. Now, the first thing is, as a building biologist, we identify health hazards in the built environment. Without doubt, testing a water damaged building is the most complicated thing we do because mould and bacteria are living organisms and they can change on an hour to daily, monthly basis depending on the psychrometric conditions: temperature, humidity, airflow. So what is a water damaged building? It's a chemical stew of biological agents from fungi, bacteria, and all their byproducts like endotoxins, mycotoxins, microbial VOCs or fungi farts, which are gases at room temperature, to things like dust mite, pests, and other things like that that are attracted to a water damaged building. We don't actually know what it is in a water damaged building that causes these asthma, allergies and fatiguing syndrome, but it seems to be a plethora of a different range of organisms that are contributing, that can result in what we call an acquired immune response and long-term systemic inflammation. Testing a water damaged building is not an exact science, and there is no one single method or instrument that you can use in isolation to do this. This is why it's really important in this 150-hour course that you learn the knowledge and the skills using a variety of different tools, which we'll go through, and understand their advantages and limitations in order to come up with a sampling plan and test that hypothesis. So the first and most important thing you do as a mould testing technician is to identify the source of moistures unique to the site that supports microbial growth, and in particular the extent of moisture in moisture-laden materials. If you don't do this, everything else you do is a complete waste of time because you will not prevent fungal particulate in that environment. All the amount of fogging and biocides are useless if you don't get to the source of moisture, because of course once moisture is there for 48 hours or more, the bacteria and fungi that are already sitting on the surface will start germinating and releasing spores and hyphae that in high numbers can cause serious adverse health effects. Again, asthma, allergies, skin problems, and even chronic fatiguing-like symptoms and autoimmune related diseases. The second thing that you'll do is to determine the extent of fungal particulate spread from the actual growth. So when you know where the source of moisture is, and it's often many sources in a house, then you need to determine how far that fungi particulate has spread from that source to the rest of the house. If you do not establish that boundary, then there's no way you can establish a scope of works, which means remediation will be a waste of time. The third thing you need to do is to identify potential air pathways by which that fungi can spread throughout the rest of the house. And we'll go through some examples, but common ones are exhaust fans, where you've got mould in a bathroom and then you're spreading into the roof void and then to other parts of the house. It could be chimneys, it could be lift pits in multi-storey apartments where you've got water in the basement or lift pit and that's now spreading to various floors throughout the building is a problem. Stairwells, because hot air rises. If you have rising damp or moisture in a bottom floor, ground floor, then of course that can rise to other areas as well. So understanding those pathways is really important. The fourth one is providing recommendations. And what we often do as building biologists is refer, and then refer again. So we'll talk about the different technicians and professionals that would often refer to. So let's start with the first one. The first goal, and this needs to be imprinted in your brain, is to identify the sources of moisture unique to your client's site. Now, the first thing I would recommend you get the client to do is to provide a floor plan so that when you write your report, you can show and identify those parts of the house that have actual growth and signs of visible mould and or odour. The other thing you want to do, often before you go to the site, is to research the area. You want to research the area for the climate zone that it's in. You want to research the area for the average rainfall, temperature and relative humidity, which you'll often get from the Bureau of Meteorology. So if you have relative humidity that's sustained for more than 3 or more days, then you're going to have high risks for condensation and mould related problems. So therefore, people living in tropical areas, far north Queensland, central coast of New South Wales, Darwin, etc., are going to be far more susceptible to visible mould and mould related problems, simply because the humidity in the air is sufficient for the microbes in the household dust and on the surfaces to use that moisture to support microbial growth. So part of your research is to do that. The second is the zoning. It's really important to look on the internet for media reports on flooding in that area. Flood zones are really important. Contacting the council or getting the client to identify if the site is on a flood zone is important. And of course, their risk for things like cyclones and other extreme weather events. There are many sources of information you can get from this. As I mentioned, the Council, the Bureau of Meteorology, and of course Google. In terms of solar orientation, it's so important. When you're first assessing a site, you want to know where the sun rises and sets, and in particular you want to know where the south side of the house is. And the reason is because the south side is the part of the house that receives the least amount of sun, which means any moisture or water vapour in that area is going to take a lot longer to evaporate. If it hits dew point, i.e. the temperature at which it condenses from a water vapour to liquid, then it's going to increase the risk of mould related problems. So on the south side of the home, you want to look behind, on that wall, you want to look behind curtains, behind photo frames, and of course closets where there's poor airflow. That's often areas where you're going to find mould related problems because there's not enough sun to allow that moisture in that part of the house to evaporate. And of course, one of the most important skills that you will implement as part of your inspection is a site inspection. Very important. The first thing you're going to find and focus on is how can moisture penetrate the building envelope. You're going to assess the walls, any cracks and leaks, how well windows are fitted into their that there are no gaps between them. You're going to look on the roof if you can for any missing tiles, problems with flashing, rusting, anywhere that there's holes poking through the roof. You want them for vents, etc. You want to make sure that the flashing around them is competent and it's not compromised at all. You're checking for any way in which it can come in. Gutters, of course, are a big one, and downpipes. Often the gutters are clogged, which means water can go back into the roof void through the eaves, and of course they can clog the downpipes. Very important that there are downpipes every time that the roof changes direction. There should be a downpipe. So make sure they're sufficient, and at least every 12 metres. So they need to have enough downpipes to make sure that stormwater is sufficiently removed from the roof space as fast as possible during an extreme weather event and away from the building. So there are 3 types of moisture that we'll go through in this subject: external, internal, and construction. And as it's already talked about, I'll briefly go through these. We've talked about external moisture, and the big one is living in a humid climate, which I've already mentioned. Natural events, cyclone, storm, flooding, leaks through the building envelope as a result of cracks, and I've mentioned other areas there. And of course, wind-driven rain can be a difficult one to identify, but often you'll find on one part of the house where there's no eaves, you'll have wind-driven rain coming in, and it can cause patches of visible mould and high levels of moisture in that area. So it's important to know where wind-driven rain and where weather comes towards the house. You've got things external, like how well is water diverted away from the house. So in your inspection, making sure that water doesn't have positive fall towards the building, that you want to make sure there's no water pooling near the building, there's no signs of lichen or moss because it needs significant moisture to support it, that the hot water service overflow isn't just going into the ground and into the subfloor. You want to make sure taps are properly drained, and most importantly, that they're not on a slope. If they're on a slope in a hill, built into a hill is a disaster, or on a slope at the bottom of a hill, you can't spend enough on drainage. You want to make sure that the water is diverted away from the house. And more often than not, most of the audits I do there is insufficient drainage immediately around the home and there's problems with water pooling. It's important to ask your client during the questionnaire and interview, during a heavy rain event, where does water pool around the house, and make sure you go to those areas with your visual inspection torch and of course with your moisture meter to identify if there's sufficient moisture wicking up those parts of the house that are going to support microbial growth. Just to give you an idea of subfloor moisture, a 93 square metre dry soil under a house will evaporate around 45 litres of moisture per day, and that's in a healthy, normal, dry home. If that soil is wet, it can evaporate up to 180 litres, which of course is 4 times more moisture. So just visualise this. If you have any moisture in the subfloor on the soil, then what can happen is that you've got huge amounts of water vapour coming off that soil, and that could be wicking up into the house. You want a really good subfloor void, and unfortunately, because housing is built so cheaply nowadays, if they have a subfloor, it's really small, and that's a problem, because if it's wet, then of course you're going to get this high amounts of water wicking up into the house, creating a rising damp problem. Flood events, of course, were mentioned. Internal moisture. So, you know, asking clients have they ever had any floods, overflow of, tubs, laundry, baths, showers, anything like that. And of course, most of us, I've had several floods in the house from leaving the plug in from the bath and it's gone into the hallway, etc. Very important, if they have a flood event, ask them how quickly they dried it out. It needs to be within 48 hours. After 48 hours to 72 hours, it goes from a water damage restoration job to a mould remediation job, because the microbes sitting on the surfaces in the house and on the floor are going to utilise that source to support microbial growth. Plumbing issues. Flexible braided water hoses are a disaster and the #1 cause of water events in Australia, and they're a big problem. So make sure that they are replaced at least every 5 years, that there's no corrosion or stain, any corrosion of the braid, and no moisture on it. That's important. Also, waterproof membranes are a huge problem, and I've gone into detail in this in the course notes, but just be mindful, if they've had a renovation since around 2005, that the waterproof membrane may only have a service life of around 7 years. So after 7 years, there could be moisture penetrating into that wall and creating microbial problems. You may need to do a wall sample on the other side of the wall of the shower, for example, to see if there's any microbial growth before they renovate and take off the, pull down that bathroom. So this is why it's important to educate people to get good quality waterproof membrane sheets, PVC sheets, for example, that have a service life of 25 to 35 years, as opposed to liquid-based membranes, and make sure they always have a company who just do waterproofing to do the waterproofing in their home, not a conventional builder. Because you'll find that the technicians will be skilled at being able to apply that waterproof membrane properly, and of course using a better quality product. An extra $1,000 for a bathroom reno means that your reno could last from a 7-year service life to 35 years, so it's well worth spending the money. We've talked a lot about waterproof membranes and problems. Now, in terms of water vapour, if you have a high level of water vapour in the house, this can be created from the occupants. In fact, it often is. So when you assess an empty building, that can be a problem, because firstly, an empty building means that you don't have people, contributing to 10 litres of water vapour per person per day. That 10 litres of water vapour includes what they breathe out. It's about 3 litres of water vapour per day, what they're breathing out. Washing, cooking, bathing. So if you're assessing an empty apartment or house, you don't have all that water vapour in the air, which means that growth, that fungi, may not be growing and your air samples may be unremarkable. If that's the case, you need to do a lot more surface samples. In addition to that, if it's an empty house and has been empty for more than 4 weeks, then you don't have the disturbance from people walking and doing their daily activities, which causes disturbance of the fungi, and that means you're going to more likely have higher levels on your air samples. So make sure in your reports you state that whatever you're picking up on the air samples is likely to underestimate what's going on in that apartment or house, because no one has been living there. Sources of water vapour, as I mentioned, people breathing out. Humidifiers, always ask people, do you ever use a humidifier? For example, if little Johnny gets asthma in winter, do you have a humidifier pumping out steam? That's bad, don't do that. Indoor pool spas are a disaster. You really want to make sure that they have dehumidification to pull that moisture out. Steam cleaning carpets. I've had many clients who've got very contaminated homes simply because they're steam cleaning their carpets every month, every 2 months during winter, which means a carpet doesn't dry within 48 hours, and now it's supporting microbial growth and contributing to high levels of fungi in that air of that home. HVAC systems, so split systems, heating, ventilation, air conditioning systems must be serviced. There should be no dirt or dust in the service because that's what your microbes will be growing on. Traditionally, microbes don't feed off plastic, but they do off the dirt. So it's important that HVAC systems, heating, ventilation, air conditioning systems, are regularly cleaned so they have absolutely no dirt in them, and they're properly sized for that room so that they're cycling properly. Otherwise, they can create high levels of condensation, which can result in high levels of mould that spread throughout that house. And many houses I've seen, that's the major contributing cause of mould in that environment. Construction moisture, this is really when you're building a house, if they've left the timber frame outside getting wet, that can support growth like trichoderma fungi. Often you have fungi already on the timber because it's been sitting in a meal or in plastic where it's got condensation and problems. Construction moisture, each cubic metre of concrete requires around 210 litres of moisture, and 90 litres of that must evaporate. Now, very rarely are builders going to allow that slab to evaporate and cure because of time restrictions. From my experience, just having a concrete slab and then masonry or timber frame or cladding doesn't generally cause problems. But if you're in a multi-storey apartment with tilt concrete slab walls that haven't cured, then that can result in significant water vapour in that apartment, which can cause mould. So that can be a problem. Many of the new energy efficient homes are so tight, especially I've had old homes in the 80s with double and triple glazed windows that are so tight that now they've got huge problems with mould because the water vapour from people just being in the homes can't go anywhere. So that's a disaster. I'm really anti this whole tight energy efficient. It's very important if they have 8-star energy rated homes or more that they have permeable wraps to enable water vapour to move through the building envelope. So with your visual inspection, you're going to use a variety of tools. I'm just going to summarise what we've already discussed. The most important is a torch. You want to look under appliances, especially that are plumbed. You want to look under furnishings. You want to look under fridges. You want to look into vents. You want to look into the HVAC system if you can. And you use a variety of different instruments to do that. You can see the torch will be the most important, and you'll carry that with you everywhere. A camera, of course, most of the time your phones can be used as cameras to take pictures of any signs of condensation and, of course, mould. You want a mirror. So having a mirror on a pole is useful because you can have a look under your appliances for signs of vermin, which is often there if there's moisture, any staining and anything like that. And of course a ladder to be able to look into the roof void. Don't ever get into the roof void unless you have this appropriate certificate of health and safety to do it. But I will put my head through the manhole of the roof with my full face respirator just to have a look and a visual inspection with my torch and my camera. Carpet pick, very useful to pick up the carpet in order to check the smooth edge and the underlay for any signs of moisture or vermin, which could be signs of moisture as well. And of course the borescope is fantastic. They're not very expensive. You can put them through the vents, through your roof vents for your HVAC systems, into the subfloor vents to look into the subfloor to see if there's any moisture or lichen or efflorescence on the soil of the subfloor, but borescopes are fantastic. Under appliances you can see quite a lot as well and take pictures. Signs of moisture, you're looking for staining on roofs anywhere, so it can be that brown staining. You're looking for cracks. As soon as you see cracks in walls and any peeling paint, that can be a sign of moisture. Any cracks in walls of the house could be indicative that the waterproof membranes are now compromised. So I always highlight that in the report. If I see a crack in a wall, that therefore if the stumps have moved or if the house has moved, that it could be compromising the waterproof membrane, and therefore a specialist waterproof membrane consultant should be employed to assess that. Visual inspection for signs of moisture, delamination of particle board. So when the particle board starts to split and separate, we call that delamination. Efflorescence on the soil. You can see here on the soil you've got this white like salts on the top of a soil. I don't want to see that, especially in the subfloor. Remember what I said, that if you have a wet subfloor on the soil, then it's going to increase the water vapour coming off that soil by 4 times. And of course, that water vapour eventually could wick up into the house, and you definitely don't want to see that. Here you can see lichen on the roof, so there's enough moisture on the roof that's supporting plant growth. And of course, if you see moss and other things around the ground near the house, that's a problem because it needs sustained moisture to support that growth. So that's important to highlight that and take pictures of that in your visual inspection. Signs of condensation, well, in these examples you can see there's actually moisture on the wall. Can't see it so well here, but there's actually condensation and water dripping off the window. Same with this here. And in fact, this was the same area here. The roof, the ceiling is buckling because there's a balcony above the ceiling. Whenever you have a balcony built into the house where there's a living space underneath, that is a disaster because those waterproof membranes are not designed to last more than 20-30 years. So once they're compromised, they're going to allow moisture to come in, and of course that will affect the floor below. So it's important to moisture map that well. And in this case, you can see it's all bubbling of the roof and also high levels of moisture on the windows. This was a west-facing window, so you know it should dry out, but there was significant moisture all over these windows all day long because of the moisture coming from the balcony above. Signs of visible mould are quite obvious, like on shoes, for example, behind curtains. Always look behind curtains, fabric curtains and blinds. The big one is, though, with timber, you need the torch to shine it on the side. So when you have a torch, you need to shine it not at 90 degrees, but on the side to have a look for this mottling and this type of dirt and or mould that will be on the timber. So remember, with walls and timber, get your torch and shine it to the side and look that way, not at 90 degrees. And here's another example of that there. Visible mould on carpet and smooth edge. You can see in this example on the left, that's clean. So the smooth edge is the tacks that the carpet is attached to, and of course there's fiberboard underneath. This is actually clean. This was sampled and had very little surface fungal particulate. On the other side of the same room, you have this dark colouring of the smooth edge, and you have this visible mould on the underlay and the foam, and same with this here. So this was contaminated smooth edge and high levels of fungal particulate, which we verified with a surface sample. Again, here is carpet with mottling of visible mould. Be very careful when it comes to this. You will use your carpet pick to pick it up, but you must have gloves and a full face on, and preferably a Tyvek suit. I don't always wear the Tyvek suit, but the full face is important because when you open up or peel that back, you will potentially expose yourself to very high levels of fungal particulate spores and hyphae, which could make you sick for days or weeks, and if you've got chronic inflammatory response, months. So very important whenever you start peeling back vinyl or carpet, it's very, very important that you have a full face and gloves on as a minimum. Fungal particulate in the split system, you can see here, not so well, but there's high levels of dirt. We measured this, and this was over 30,000 fungal particulate spores per square inch, which is enormous, and this made these clients very, very sick. You don't want to see any dust or any fungal particulate at all in the HVAC system. You can see here this mottling here, a big problem. They had high levels of Aspergillus penicillium, and cladosporium is something we often find in contaminated heating, ventilation, air conditioning systems. Condensing coil, very dirty here, but generally with the HVAC system, what you're looking at is with a torch, looking underneath where the barrel fan is. This is the barrel fan here, which is normally, you've got the condensing coil at the front, and then with the torch underneath looking at the barrel fan, because that's where often the fungal particulate tends to be at its highest. If you can get a swab there or sample, that's highly recommended. When it comes to quantifying the visible mould, it's important to use the NIOSH tool, the National Industrial Occupational Safety and Health tool. Now, this is a fantastic tool. I've modified it here because it basically enables us to quantify, well, each of these maps, the NIOSH tool is used for one surface. So for example, I might tick north wall. So this is on the north wall, I have 1, which means that the visible mould was up to the size of a piece of paper. If I tick 2, it means the visible mould was between the size of an A4 piece of paper and the size of an interior door. If I tick 3, it means the visible mould on the north wall of that house was more than the size of an interior door. So this is a quick way to quantify with a checklist for that room the visible mould there. They also ask about odour, and it's very important. Remember, visible mould and damp musty odour, the two most important markers you must always look for and document. If you don't see visible mould or don't smell odour in that room, you must document that. It's important to document what you don't see as well. Because they're the two most important markers associated with health effects, that's why you must always be very vigilant about using the NIOSH tool to identify and quantify the mould, visible mould. Thermal imaging can be very useful, but also a waste of time. Thermal imaging enables you to pick up temperature differences. So using your thermal camera, it will pick up temperature differences, which may or may not reflect a mould problem. So it's important, if you're using a thermal camera, you then, if you come across an anomaly, and I'll give you some examples, you then get your moisture meter to verify that it's wet. If it isn't, then it's not likely to be a problem. You'll often find anomalies because of cold air, for example, will come up with blue areas, which is similar to moisture. Because moisture, as it evaporates off the surface, it cools the temperature. That's why you see it as a bluey, purpley colour on your thermal imaging. So it's cooler. However, as I said, it doesn't necessarily mean it's mould. It could be just cold air. So you often find those in the corners, it'll be a bit bluer, etc., because the air is stale, it's not moving, and it's cooler there. So it's important when you pick up an anomaly with your camera that you then get a moisture meter to verify that. So here are some examples here. You can see that there's water wicking up. When you look at the actual photo of that building, there's nothing, you can't see anything with the naked eye, but with the thermal imaging you can see that there's actually moisture wicking up from the skirting boards up the wall. So obviously that wasn't dried properly after a flood event. You can see on this next one here that there's nothing on the ceiling of this house here from the naked eye, but when you get a thermal camera you can see this bluey purpley blob, and of course water is irregular shaped, so you expect to see something like this if it's moisture, but to verify it of course you need to get your moisture meter and pin it and identify, is the level of moisture there sufficient to support microbial growth. If you see these blobs and they're regular shape, then that's not generally water, because water isn't regular. They'll often be like with ghosting, which we'll talk about later in the course, you know, those where the noggings are, for example. So you're looking for irregular shapes like how water would flow and these darker colours, but you have to verify it with your moisture meter. Here's another example, looking at a shower, on a wall of a shower you can't see anything, but when you moisture map you can see significant moisture behind, almost covering most of that wall. So that's where you definitely will want a moisture map to verify that, and more importantly do a wall sample on the other side of the wall of that wall in order to identify if there's fungal particulate. And that's going to be important, because if they pull that down into a bathroom reno, they're going to expose that house and contaminate the house with the fungal particulate that's hidden. So this is where containment and a proper IICRC remediator is required. Surface wall temperatures are really important. Often your moisture meters will have surface wall capacity, and what you want to check is dew points. So if the surface is cool and is close to the dew point, then there's a high risk there's going to be condensation. So for example here, the surface wall temperature on this wall, which was south, remember south walls tend to be cooler, why? Because they have less sun and therefore less evaporation and moisture, was 23 degrees, which was only 5 degrees difference. So if this dropped by another 5 degrees, then the moisture in the air would hit this surface and condense. So that's important to understand surface temperatures. This is why as building biologists we don't like metal. We don't like cold surfaces like metal, granite, masonry, etc. is cold. I don't want to see a bathroom that has tiles all the way up the wall, especially in cold climates like Melbourne, because they don't have any hygroscopicity. They can't absorb and release moisture like natural materials like gyprock or timber, for example, that's untreated. So, you know, this is why you don't want a lot of cold surfaces. Ideally, the temperature of your surfaces in your house, from your furnishings to your benches to your tables, should be as close to the air temperature as possible. If they're cold, like metal, then, and granite and masonry and stone and slate, then when that water vapour hits that surface, it could condense to create condensation, and if that sits there for 48 hours, you'll have a mould problem. So moisture meter is probably the most important tool apart from a torch that you're going to have in your toolkit. The moisture meter verifies and quantifies the level of moisture in the materials, and that's important because if you've got any signs of moisture, you need to make sure that you quantify that with the moisture meter. If there's enough moisture on that surface, it will support microbial growth, and remember, the microbes are already there, bacteria and fungi, so they're going to start sporulating. Just because you can't see visible mould doesn't mean it's not a problem. In fact, we call it a condition too. You can have high levels of fungal particulate on that surface that you can't see with the naked eye. By the time you actually see it, you're talking millions upon millions of spores and hyphae per square inch to even register it as a site. So I've gone to many homes where the air samples were in the thousands of spores per cubic metre, where you couldn't see or smell mould, and the surface samples were in the tens of thousands, but you couldn't see it. They walked out with just the clothes on their back. So it's important. Moisture mapping is critical, because if the remediator doesn't identify moisture in the materials, they can do fogging, they can clean the surfaces, but if they don't get to the source of the moisture in the gyprock or on that surface, it's going to continue to create spores and hyphae, which will cause more problems. Within months, you'll get high levels again back in that room. The other one, of course, is mapping that. So you can see the figures here on your moisture meter. I love the MMS2 Protometer. However, a lot of mould remediators who do technical drying, specialist drying, will use the Delmhorst. I love this meter because it also measures temperature, humidity and absolute humidity, and it does moisture readings as well, both measure and scan mode. Moisture mapping is critical. You'll have a moisture map per surface, and you'll be documenting this. As soon as you have elevated moisture on any surface in any part of the house, which increases the risk for mould, you're going to get this, and then you're going to draw it up. So we've got detail on how to do this in the course, but basically this is per surface. Say for example this was the floor, I would then draw where the furniture is on the floor of that living room. So I'd say living room, floor, I'd draw where the furniture was, where the door was and the window, and then I would go, I moisture map this part of the floor, and I put a circle here, and then say what my reading actually was. What my reading was here, there. Remember, when you use moisture maps, your colleague or anyone who comes through this course should be able to replicate exactly where you moisture mapped. Where did you pin the floor? Where did you use your scan mode and measure mode? So you need to be able to, on each of these, this represents one surface in that room, to identify so that I could come in after you've done the audit and actually put my moisture meter exactly where you put it before. So remember, a great assessment is that the more thorough it is, the more pictures it is, etc., the more measurements you do, so that anyone could replicate your work in a court of law. Indoor air quality meters are really important because you want to identify humidity, and in particular absolute humidity, temperature and dew point. Dew point is the temperature at which moisture condenses out of the air to form liquid. Generally, the rule of thumb is if you're in a climate zone where the humidity, relative humidity, is above 70% for more than 2 to 3 days, then it will support microbial growth. So you've got microbial growth happening in the dust of the carpets because it's utilising the moisture in the air. So it doesn't have to be a water event to cause mould problems, and that's important to know. The way we identify these moisture problems is we write this down. So as part of your checklist, I've given you this as your sample checklist. You're going to say the location, the time you took it, the temperature of the air or surface, and then the relative humidity on your meter, and of course absolute. Without doubt, the absolute humidity is the most important because it's the actual amount of water in the air. Relative humidity is actually not that useful when you're doing testing a water damaged building. You want absolute humidity. Absolute humidity, because it provides us, it enables us to compare the outside with the inside. And the reason is because if you've got high levels of actual water vapour in one part of the house, it could be that there's moisture-laden materials there that are allowing this water vapour to come off, or it could be a rising dam issue, that's the subfloor's got high levels of moisture coming in the subfloor that's wicking into the house. Or it's been a flood event that wasn't dried properly, and now you have high levels of water vapour in that area. Typically you'll find it tends to be in the bathrooms and other areas like that, but that's transient and tends to dissipate within an hour. If it's sustained and they haven't had a shower for hours or half a day or a day when you've done the audit, and you've got high levels of water vapour in various rooms of the house that are significantly higher than outside, that's a problem and you need to investigate where that water vapour is coming from. The way you'd write it, so in the previous one, that's how I'd write it while I'm conducting the assessment. But when I write the report, I'd actually redo the table like this. Something like the exterior in the garden, the balcony, it was taken on the balcony and had 10.71. Remember, specific humidity is the most important thing I'm looking at in these results. So it was 10.71 on the east side of the balcony. Ideally, they would have the timing of this, because if the time is too varied, half an hour later, then of course the outside humidity can change quickly. But it was 14.95 in the living room and 15.16 in the bedroom. So you've got significantly high levels, more than 50% higher inside than outside the house. So what that's saying is there's significant water vapour in the house, and the house isn't acclimatising quick enough to the outside. And this water vapour can support microbial growth within the dust and the surfaces of the house. So you need to find out where that water vapour is. It could be something as simple as you've got a 2-bedroom apartment and there's 6 people living in it. Obviously, 6 people means 60 litres of water vapour per day, and that apartment isn't designed to deal with that amount of people and that amount of water vapour. Or it could be due to a water event, flood, that wasn't actually cleaned, so that can be a problem as well. So on to this next slide with water vapour. This is another way you can present that in the report. You can see there that the most important control will always be outside. So we're identifying what the absolute humidity or actual water vapour is outside in grams per kilogram, and then comparing it to the inside. You don't want to see more than around 10-20% differences. Obviously, it's important to go back into outside of the house at least 3 times, at the beginning of the assessment, somewhere in the middle, and then at the end. So you've got at least 3 outdoor readings for temperature, relative humidity, and absolute humidity. The closer you're comparing the temperature and humidity inside the house to outside, the more accurate it is to make a correlation. So what we're looking for again, absolute humidity is 6 and 5.67 outside bedroom, but then in bedroom 2 it's 7.8, 7.3, so that's significant elevations. So you want to investigate further why there's high levels of water vapour in those rooms. Is it that there's moisture-laden materials from a plumbing issue they're not aware of, or a drainage problem, or was there a flood event in that area that was never dried and it's supporting high levels of water vapour into that space? Remember, more water vapour in the air, the more it supports microbial growth in the dust of the surfaces as well. This is another way you can present those findings. Again, looking at the outdoors is very important. So in this example, the absolute humidity was 9.34, but it was up to 16.32 in the main bathroom. So obviously there's significant water vapour issues, especially if they hadn't had any bathing activities in the last 4 hours or so. That would be supporting microbial growth. You need to identify where that water vapour is coming from. Often in a bathroom wet area, it's because of a lack of ventilation. That's the first goal.